This is Module 4, Lesson 1, the rectangular coordinate system and graphing linear equations. So, you will see we're going to plot points first, and then we'll move on to graphing linear equations, which is a fancy way of saying just graphing lines. So we have 4 quadrants in the coordinate system: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So they're very clever because they label the quadrants with Roman numerals so you don't get confused between the numbers on the grid and the little Roman numerals denoting the particular quadrants. Now, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. So, ordered pairs, we're going to need an x-coordinate and a y-coordinate because we need a location on the plane. And so in order to get a point on the plane, we need some kind of horizontal movement and then vertical movement. So now we're going to plot these points here and then figure out what quadrant they're in, if they're in a quadrant at all. For example, 0, 0 is right here, and that's called the origin. So it's not really in a quadrant, it's just right smack dab in the middle. 1, 2 means the x value from the origin, I'm going to the right 1, and the y value said let's go up 2. And there it is. That's the point 1, 2. And you'll notice that is in quadrant 1. Now, 3, 4 means from the origin, we're going to go to the right 3, and then we're going to go up 4. 1, 2, 3, 4. Again, we are in quadrant 1, and this is the point 3, 4. The next is 5, negative 4. So that means we're going to go from the origin over 5, and this time down 4. This is the point 5, negative 4, and it looks like it's in quadrant 4. The next one is negative 4, 0. So I'm going to go to the left, 1, 2, 3, 4 on the x-axis. But notice we don't move at all. We stay right on the x-axis. So it's really technically between quadrants 2 and 3. So we just say that it's on the x-axis. Okay, so I didn't follow my little directions. I should have written none. It's not in the quadrant, so N-O-N-E. I just like to be a little bit more specific. None on this. Okay, and this is the point negative 4, 0. Okay, next, negative 2, negative 2 means I'm going to the left 2 on the x-axis and then down 2 from there. So this is negative 2, negative 2. It's in quadrant 3. I don't know why quadrant 3 is my favorite quadrant. I have no idea. 0, 2 means I start and I don't go anywhere, move anywhere right and left, but I am going to go up 2. So this is the point 0, 2 right here. And I'm going to follow directions, none, but I can't help myself. I'm saying it's on the y-axis. All right, now we are going to look at equations of 2 variables. Okay, a solution to an equation in 2 variables must consist of an ordered pair that makes the equation a true statement. So for all of these, we're going to determine if the ordered pair is actually a solution to the given equation. In other words, it makes it true. So the first one is x plus y equals 5, and the ordered pair is 3, 2. So that means I'm going to put 3 in for x, because that's my x-coordinate is always your first coordinate, 2 in for y, and it equals 5. Is it true? Yay! So we say yes. 3, 2 is a solution. Great. So let's look at the next one. 3 comma 2. Again, I'm going to pop 3 in for x, 2 in for y, and obviously 1 does not equal 5, so no. 3, 2 is not a solution. Okay? And now let's do the next one. 2x minus y is equal to 5. So I really need 2 times x minus y equals 5. And I did these little open parentheses because then I can just pop in the values. 3 for x, 1 for y. 2 times 3 is 6. Take away 1. Again, this works. So yes, 3, 1 is a solution. And last but not least, I am going to pop in 8 for y and 3 for x. And you just have to be careful about where things are located. You know, just think and relax and pop them in. 3 times 8 is 24. 2 times 3 is 6. Well, 24 doesn't equal 12. So that's a big NO, not a solution. Perfect. On to the next. Now we're going to start graphing lines using a table. So we're going to fill in a table of values and then we're going to graph the lines. And it is all hinged on what equation they give you. So it's x plus y equals 5. So we're going to be given one coordinate and then get the other coordinate and then list the ordered pair and then graph it. So for our first one, x is equal to 0. Recall, this is our equation. And some equations are going to be easier than others. We started off with a fairly straightforward one, so I'm going to put 0 in for x. And now we're actually back to solving linear equations. Y is equal to 5. So I put a little 5 in here. So now we have an ordered pair 0, comma 5. Yay! All right. Now let's do the next one. Well, I gave you a value of 1 for x, so we know my equation. So I'm going to put 1 in for x and figure out what y is. Now this is fairly straightforward, you guys. So don't go, I can't believe she's doing something so easy. So y is equal to 4. So I write my little 4 in, and then I write my ordered pair. And last but not least, this time I'm having you put 0 in for y into the equation. So the equation is x plus y equals 5. I'm going to put 0 in for y and figure out what x is. Well, x is 5. I know you're not shocked. So I'm going to pop it in. So 5, comma 0. So now what we're going to do is graph these pairs. 0, comma 5 is the one that we're going to do first. That means I don't go anywhere on the x-axis, but I'm going to go up 5 on the y. There it is. 1, 4 means I go right 1 on the x-axis, and then I'm going to go up 4. 1, 2, 3, 4. There it is. And then last but not least, 5, 0. I'm going to go 5 over on the x-axis, and I'm not moving on the y. So let's see how well I can draw that line and connect those points. Not too bad. So this is the line, x plus y is equal to 5. Now, yes, it only really takes 2 points to form a straight line, but I like that third point to make sure that I am not doing anything incorrectly. If I plugged in wrong, there could be an issue. Okay, on to the next. Okay, this equation is a teensy bit less straightforward than the first one, but here we go. So I'm going to say y is equal to 2x plus 5. So now I am going to pop 0 in for x, y, because I picked it. So y is equal to 2 times 0 is 0 plus 5, which equals 5. So I'm going to put a little 5. And it's really not that, 0, 5 won't always be on every single line. I just chose that. Okay, let's do the next one. I requested x to be -1. So here's my equation. And then I'm going to pop in -1 for x. Now you're like, this takes so much time. When you get good at it, then you can eyeball it. But until that time, just take your time, plug in, get the right answer. -2 plus 5, well, that's 3. So it's -1 comma 3. And then last but not least is I'm going to put 0 in for y this time. So you're like, well, why would you ever want to do that? Well, sometimes you want to find where the graph crosses the x-axis, and you're going to have to put 0 in for y. So 2x plus 5. So I'm going to subtract 5. So don't forget, solving your linear equations will come in handy in this section. I'm going to divide both sides by 2. So x is equal to a -2.5 when I divide that out, or 2.5, or -5 halves. And so now let's graph this. It's -2.5. So we'll graph all 3 lines. The only one that's kind of iffy is the -2.5 one. Yeah. So let's do 0, comma 5. So no movement on the x, but up 5 on the y. There he is. -1, comma 3. Going to go left 1 on the x and up 3. There we go. And then -2.5, comma 0 is right in between -2 and -3. I almost said that incorrectly. And nothing on the y. Let's see how well I can connect these. Nah. Okay, so this will be y is equal to 2x plus 5. Great. Moving on. So this is a really neat equation. X is equal to 5, which means that y can be anything its little heart desires because the equation doesn't say anything about y. So if the equation contains only x equal to a constant, like 5 in this case, y can take on any value. So let's just make some up. 0, 1, 2. Great. So 5, comma 0, 5, comma 1, 5, comma 2. So let's just graph it and see what happens. So 5, 0, 5, 0, 5, 1, 5, 2, and I draw this line. It's a vertical line. In fact, x is equal to any constant is a vertical line. Okay, so this is the line x is equal to 5. Okay, now we're just going to graph a linear equation from scratch. I'm going to make a table. Because I'm not given any values, I have to make them up. The easiest values to pick are 0 for x and 0 for y, and that's kind of like a tic-tac-toe. And yes, I can make another point here, and I'm going to try to tell you the values that will allow you not to get fractions. Okay. So when x is 0, we're going to put 0 in for x to the equations. 2x plus 5y is equal to 10. and we put in 0 for x. I know that I'm writing out all the steps because it's good. 2 times 0 is 0. 5y equals 10, y equals 2. So 0, 2 is your ordered pair. Okay? And then let's do the 0 for y. So 2x plus 5y equals 10. And again, some of you might just be able to eye it and figure it out. And eventually, everybody's going to be able to do that. Eventually. So don't get down on yourself if you can't do it right away. Who cares? As long as you get it done. So x is 5. 5 comma 0. Okay. Now we could stop there. 0 comma 2. 0 comma 2. And 5 comma 0. And I've graphed the line. Okay. A foreshadowing for the next couple of sections is this is called an x-intercept. And this is called a y-intercept. Okay. Now, you might be saying, well, where's the third point? And in this case, our grid really only goes up to 5. So if we picked something else, let's say if we let x equal to 1, let's do that. We will get 2x plus 5y equals 10. 2 times 1 plus 5y equals 10. 2 times 1 is 2. 5y equals 8. Y is equal to 8 over 5, which is 1.6 when you do that. Divide it out. All right, let's see if we're pretty good. 1.6 should be right about there. Not too bad. However, if you're faced with making your own grid, and in this case we only went up to 5, and we probably should have gone further, maybe up to 20. If you choose a multiple of both these numbers, we're good. So for example, if I chose x to be 10, okay, because 2 times 5 is 10, so it is a multiple of both 2 and 5, and I throw it into the equation, I will get 2x plus 5y equals 10. 2 times 10 plus 5y equals 10. 2 times 10 is 20. I'm going to get 5y is equal to negative 10. Y is equal to negative 2. And that's really nice. Okay, and we can kind of see as we go out here, it'll be another here and down 2. So I'm thinking we're pretty good. So the multiple thing really works if you want to get whole numbers. All right, now you're going to be able to do the worksheet for this lesson and then my math lab exercise. Good luck.